Now look at the next part of aldehyde ketone, part 4 of aldehyde and ketone. So question number 13 asked in 2015. Reaction of carbonyl compound with one of the following reagent involves nucleophilic addition. So what it does, there is carbonyl compound, right? So it react with nucleophilic addition. So it does nucleophilic addition reaction. Addition reaction. Elimination of water is does. So what it does, it removes the water. So the reagent is, you have to tell me. So which reagent you are using? So reaction of carbonyl compound with ammonia derivative give additive product followed by elimination reaction. Derivative of ammonium. So it will be like RC double bond O NH2. So this is called amide. So this functional group is called amide. Right. Slightly acidic medium generator nucleophilic reaction. Base with ammonia derivative. Right. So how it happens? Suppose I am taking carbonyl compound R C double bond O. Here carboxylic acid is there. So when it react with ammonia, so NH2 and H is there. So this will be plus and this will be minus. In the similar manner, this is your OH minus and this is your plus, right? So this OH minus go with this H and this NH2 minus attach with this. So this is your carboxylic acid reacting with ammonia to form the derivative of amine. So it will be RC double bond O NH2. So it forms amide. Understood? So asked in 2015. ये समझा आपको? Understood this one?
Yes, sir.
Okay. So this is basically carboxylic acid reaction with the ammonia. Now look at the question number 14. Treatment of cyclopentanone with methyl lithium. Which of the following species? तो देखो इसका स्ट्रक्चर बना देता हूँ. साइक्लोपेंटेन मतलब 5 कार्बन हो गया, ये डबल बॉन्ड O हो गया. दिस इज कॉल्ड साइक्लोपेंटेनोन, राइट. रिएक्ट विथ मिथाइल लिथियम मतलब CH3I, मिथाइल लिथियम. दिस इज कॉल्ड मिथाइल lithium. So what will be the formation of the product asked in 2015? So see here, metal. This is metal lithium, so it will form plus cation, and this will be the minus part. Understood? Cyclopentanone. So first reduce into metal. This is first do reduction. This is cyclopentanone, no? So first do addition of hydrogen, so it is converted into HH. Here double bond O is there. So when it react with methyl lithium, so this is plus, this is minus, right? So this will be plus. As we know, hydrogen having 1 electron and carbon having 4 electron in last orbit. So it will be minus. So minus will attract now plus lithium. So it will be attached here and this will go with this CH3. So what will be the formation of product. So here lithium will be attached double bond O, and next is CH3H. So this form methane CH4, and this is your lithium cyclopentanone. Name of this compound will be lithium cyclopentanoyl anion. This is called intermediate also. Write it down. Now look at the next question, 15 number. Uh, Asked in 2000 is not given. No? Asked in 2015. So compounds are given. Which of the given compound can exhibit tautomerism? So I will write the compound for you. Suppose this is cyclohexanone double bond O. Double bond is here. This is CH3. This is CH3. Right. And another compound is cyclohexanone. Double bond is here. Here CH3, CH3. And third compound is also given. So I will write here. So this is your first, this is your second, this is your third one. So you have to do tautomerism. So what is tautomerism? Double bond go with the more negative atom, right? So we will do the tautomerism here. So see, in first compound, here this is your carbon, right? So four bond is there. So one, I will write the hydrogen for them. So carbon make four bond, one, two, three, four, right? And this is your also carbon making double bond with O. So what will happen in tautomerism? This pi bond is shifted to this carbon and one hydrogen will come here. So then it will look like this. So this will be OH and double bond will be here. And one hydrogen will be remaining. One is shifted here now with OH. And this will be the branching of CH3. So this is the tautomerism. Tautomerism. Understood? Now look here in the second compound. Second compound, I have made this one wrong. So I will correct it. This is CH3. So in second compound, so this carbon having four bond, two with the hydrogen. So again, this pi bond is shifted here and double bond shifted with this carbon carbon and hydrogen is shifted with oxygen. So it will be like this. So it will be double bond and this will be OH. And here CH3, CH3. This is your double bond. Understood?
Yes, sir.
Now see the third one. So carbon here making four bond with branching CH3, right? And here this hydrogen is having two hydrogen atom. So what will happen? It will do now shifting of pi bond. So see here, this pi bond electron will be shifted to this oxygen. So it will form minus, right? And this carbon pi bond will be shifted here. And hydrogen is removed. So one will be shifted here. So it will be looking like this. This will form OH and this is pi bond. And branching of this carbon is CH3 and CH3. right? So answer will be all of these three. So this is also doing tautomerism, this is also doing tautomerism, and this is also doing tautomerism. So option will be all these three. Asked in 2015. So very important. So practice at home, right? How to do the tautomerism. Now look at the question number 16. 16. An organic compound X. ठीक है? Organic compound means it contains carbon and any other atom like hydrogen, oxygen, like that. It may be nitrogen, sulfur. So in organic compound, main element is carbon, right? Its name is given X, having molecular formula. So molecular formula for X is given, that is C5H10O. Produce is phenyl hydrazone. It produce phenyl hydrazone. Phenyl hydrazone. And give negative response to iodoform test. And it doesn't react with iodoform. Iodoform. It doesn't do, right? And Tollin test. And it also don't do Tollin test. Tollin's test. It produces N-pentane on reduction. So when it do reduction, it forms pentane. Pentane. So you have to tell me what is X. Asked in 2015. So see here, as the compound X produce phenyl hydrazone and give negative iodoform test and Tollin. So it contain double bond O group, neither a methyl ketone nor in aldehyde. So this can be written as, so this will be your ketone, not aldehyde, because this iodoform and Tollin test is do by aldehyde only. So it confirms that, so this compound, this molecular formula doesn't contain aldehyde. So it must be ketone. So write the ketone general formula. Molecular formula is C5H10O. So ketone is C double bond O. How many carbons are there? 5. So I will write 2 on left and 2 on right. And middle one is forming ketone. So this will be CH3, CH2. This is CH2, CH3. Right. So this will be the structure of X. So name should be given, right? 1, 2, 3, 4, 5. This is your pentane. So this will be your pentanone. 3 on. 3, why I am writing? Because at 3, it is forming double bond O, right? So this is the functional group of ketone. Functional group of ketone. Group of ketone. And as we know, ketone general formula is RC double bond O R. This R and this R should be same, or it can be different also. So in this case, this R and this R is same. So this is your symmetrical ketone. This is your symmetrical ketone. Symmetrical ketone. Write it down now. Now look at the question number 17. Reaction by which benzyl aldehyde can't be prepared. Right. So all options are given, but I will tell here. Suppose I am taking benzoic acid. One option is given, benzoic acid, COH, right? Cyclobenzoic acid. When it do react with zinc and amalgam in presence of conc HCl, it forms acyl cyclobenzene. So it will form C double bond O Cl, and formation of water is done. So it is not used in the formation of benzyl aldehyde, right? This is your option D. So when you look at the option one first, methyl benzene is there. It react with CrO2, Cl2, and CH2, carbon disulfide, and chromyl chloride. So it forms intermediate and forms lastly benzyl aldehyde, CHO. So it is used. In the similar manner, B option and C is also used, right? But D we can't use for the preparation of benzyl aldehyde. So mark it as D option. Now look at the question number 18. क्या बोलता है CH3CHO. So CH3CHO is nothing but aldehyde. So this is your ethanol. Two carbons are there and we use al for aldehyde as a suffix. So you can draw the structure also like CH3, C double bond O, H. And next compound is C6, H6, CH2, CHO. Right. So I will draw the structure for this also. This is cyclohexane with CH2, C double bond OH. Right. So how will you distinguish between these two compounds? Asked in 2012. Right. So how will you distinguish? So this aldehyde can react with NOH, which do aldol condensation. Aldol condensation. Right. And I2 to give the iodoform test. And it also do iodoform test. Iodoform test. While this doesn't react with it. So this is not done. So it will not give your aldol condensation and iodoform test. So iodoform test. Now I will write the reaction for ethanol CH3 C double bond O H. So when it react with like iodine CI2 plus 4NOH. So it will form CHI3. This is your iodoform. Like chloroform, bromoform. When it is iodine, then it is called iodoform. And next one is CCONA. And 3NAI form and 3H2O. Right. So main compound is this one. So this one is these three are byproduct. Byproduct. No need to write byproduct. So you have to just write it down. Iodoform. So for iodoform, compound should be aldehyde with CH3 group. So this reaction is called iodoform reaction. Now look at the next question, 19 number. So predict the product in the following reaction. So this is your reactant given to you. This is Cl, this is CHO. So when we start naming, so this carbon will be given 1, 2, 3, 4, 5, 6. Right. So when it react with 50% of KOH, potassium hydroxide. So what will be the formation of the product? Asked in 2015 in AIPMT 2012. So what it does, 50% KOH is used. So one will be converted into two product will be formed. One will be converted into alcohol and one will be converted into potassium, carboxylic potassium. Like I will make the diagram then. So this will be the cyclo and this aldehyde will be converted into CH2OH. So this is your alcoholic compound and next one is, so this will form like COK carboxylate, and here chlorine will be there. This is also called Cannizzaro reaction. So this is called Cannizzaro reaction. So simple way to remember it, when aldehyde is react with any bases like KOH or it may be NOH, right? So one will be converted into alcohol and there will be carboxylic acid. So right here as a RCOH general formula. When base is there like NOH or KOH is there, so one will form like R. This is your aldehyde, right? So correct it. So this will be the aldehyde like C double bond OH. So one will be converted into alcohol and one will be converted into carboxylate group, or instead of K it may be Na. So in Cannizzaro reaction, one aldehyde is converted into alcohol, and one is converted into carboxylate ion of potassium and sodium. So this is your aldehyde. So write it down.